Hi, folks. Nice to see you all here. Just testing the mic here. My name is Alona Nadler. I'm AWS Glue Head of Product. And with me today is Ralph Peterkin, who is a Principal Technical Architect from Disney. And what we wanted to do today is share with you a little bit how Disney uses AWS Glue for data integration, for self-service ETL. And to do that, I'm going to level set a little bit this conversation. We're going to talk about what is data integration very quickly, just so we level set everybody is here in the crowd. We're going to talk about some of the challenges that we are seeing customers having these days. And then I'm going to do a very brief introduction of Glue, AWS Glue, for those who are not familiar. So when Ralph comes in, he can dive into the details. So with that, I'm going to kick us off. So in general, just to level set everybody, data integration usually starts when somebody is asking for a new report, a new dashboard. There is a question that nobody can answer with the existing data. It might be a team that needs to share data that's coming from a different team. Or it might be a data scientist who wants to combine multiple data sources together and requires some help or efforts to do that. And what tends to happen in many organizations is then somebody needs to go ahead and build a data pipeline. And that usually means that first they need to understand the business requirement, what exactly is needed. They collect those, they understand those, and they start by getting access to data, which is trivial for many enterprises today. They learn the data, they understand how it matches to what they're trying to achieve. And oftentimes they need to filter the data, they need to aggregate it, they need to join it with other data sources. And especially these days when you have so many sources, it's not trivial. A lot of the times the data is in different granularity, and in order for that to match nicely, you need to do a lot of transformation work on that. But once it's achieved, we're testing it, we're validating it, and it's usually an iterative process. We look, we visualize it, we see that we missed something, we go back to the editing board and do that again. And then once it's achieved, we usually have the third part of it. Okay, we have now the data integration, data pipelines. How frequently do we actually need it? Is it 24 hours, every 12 hours, every 2 hours? What is the business requirements for that? And this is setting the SLA. And once we know that, we usually create a workflow. It's either by schedule. It might be based on event trigger that spins off this data pipeline. And so by the time we sort of have that ready, we're done, right? But we usually need to continuously monitor it and see when something is going wrong, what happens. Is it a schema change? Is it a bug in the system? And we actually need to spend quite a lot of time troubleshooting it. So what we call data integration is everything that is evolving across the build and operationalize area. And this is what we call data integration area. So seems complex, and when we're talking to customers these days, especially in AWS Glue, we see that they have multiple challenges. And usually it's a combination of people, of processes. When it comes to the business team, we see that usually they want to do self-service. They want to get the data and from there pick up by themselves. Probably most of you are familiar when a data pipeline is missed, something is completely off in the data. You see that it doesn't make sense. So we often see that customers, when they messed up a pipeline, you can no longer use the model or the dashboard. And when it comes to data engineering themselves these days, they have a lot of infrastructure management to handle. They need to find a way to scale their systems. And we've seen a tremendous growth in data ever since COVID started. And companies and data engineers needed to cope with that. And they also need to move around multiple tools to achieve that. And in the very left side, we have the IT leadership challenges, which are we want to keep things under the right cost, so it's not going to get too expensive. We're trying not to have too many solutions in many cases. We don't want to lock in, so we don't want to commit to a proprietary solution that we'll stick with. We'll have to commit to it for many years. And we're trying to find a solution that will benefit how many as we can from the organization. So With that, those are the people's problem. But now we have also data challenges. Those are evolutions of what we see in the data space. We know the data is growing, and that forces a lot of companies to figure out how they scale. So in the past, or in the last several years, we see that in many data engineering teams, they serve as the gatekeeper, because they need to prioritize all the requests from the organization to figure out what can they do, because they have limited infrastructure. And we also see that they have a lot more new sources these days. We're talking to companies, they say that in order to introduce a new data source, it takes them months, sometimes even years. And how can we reduce that to a few weeks or a few days or a few hours? And we also have an increasingly diverse data. So we have multiple formats, multiple file types, and different sources that don't really, the data is not really in a shape that can immediately be joined together. And that creates a lot more need for transformation, which requires some processing power. There is a lot more work to be done into the data in order to join and make sense out of it. And in the end, it's actually a positive trend that there is a lot of application using this data today. If you have internal systems, you might have partners, you have customers, end users, and they're all using the data. But it also raises a challenge in keeping those systems secure and reliable so we can count on them for the long run. And those are a few things that we see from a lot of organizations that we're working with. And the options that we have today in the market are sort of like in the two spectrums. On the one side, we have traditional ETLs. Those are usually very comprehensive solutions. They were built 10, 15 years ago. However, they have some challenges when it comes to their scalability, because they didn't have to cope with the amount of data that we have today. They also have high licensing costs, often, is what we hear from customers. But especially if you think about it, when it comes to data integration, you run a job every 12 hours, every 2 hours. Most of the time is idle time. And for many customers, they still need to keep the infrastructure, they still need to keep the cluster. All the processing power is just standing there waiting for the next job. On the other side of the spectrum, we have kind of like the do-it-yourself platforms. So these are open source like Hadoop, like Spark, really powerful, a lot of vibrant community around them. But you do need a dedicated team that specializes in that. You need the knowledge in order to operate them. You need often an admin to manage that and maintain that. And you still need to maintain your cluster, even if you use it or not, even if there is a job running or not, you have the cluster. And when we built Glue 5 years ago, Glue is a relatively new service for AWS. We thought what we can do to combine those two worlds and get the best out of it. And one of the fundamental things is about how can we have a serverless service, and we built it from the ground as serverless. And the reason it's very powerful is that you don't have to care about idle time. We have all the capacity that you need. Focus on the data. We'll manage the infrastructure for you. And it allows you to do a lot more when it comes to data and help the business than to run around infrastructure. The second element is that you only pay for what you use. And if you have a job once a month, this is the only seconds that you're going to pay us for. And we'll still maintain everything as is and give you the best service. And to combine it with, really, when we said combine two worlds, we're using in Glue open source engines. So you still get the benefits of this vibrant ecosystem. And we are supporting multiple open source engines, which I'm going to show you in the next slide. And in the end, we also added an abstraction on top of those, because we know we are having multiple personas, multiple users in the organization, and we want to support them. And we built multiple ways to author, to operationalize, based on your skills, based on your needs, so we can support more users in the organization. So when it comes to Glue, we look at it in 5 layers here. I'm going to touch quickly upon that, and if you want to learn more, you can join us to one of the many sessions that we have here in re:Invent. But I'll start actually from the bottom, from the engines. So when I say engines, I combine the serverless infrastructure that we manage and the data integration engines that we have. And what it allows you to do is that we can spin up clusters for you and nodes for you in a matter of seconds. To be more clear, we can spin up 300 nodes in 5 to 10 seconds, if that's what requires to your job. So you're no longer bound by just the infra and the capacity that you have. There's also a per seconds billing. So you actually pay for only what you used, precisely what you used. So it's a great benefit when it comes to cost, but also the service that you can give without worrying about infrastructure. And to make it even more cost effective, we've added in the past year, in the past 6 months, various capabilities that helps you when it comes to auto-scaling. We've seen that customers don't know how to manage their capacity exactly. So we now can do that for you. If you're using, for example, Spark, we know how many, we look at the job, and when we run it, we know how to scale up and scale down the amount of workers that you have. And customers save between 20 to 40% just using the auto-scale. On the right side, we introduced Flex, which is our version to spot instances, so spare capacity. And at many customers, you have the critical jobs. So you need a standard execution. You don't want it to fail, but you also have non-critical jobs that maybe you can benefit from 34% discount and run them on our spare capacity. I talked a little bit about the Glue engines. So we support, as of today, 3 engines. We support Spark, which is very popular among our customers, and many of them are using that. We also support Python shell for smaller workloads for Python. And today, we actually announced a new introduction of Ray as an engine. And Ray is an open source project based on ray.io, which is really, we found it really promising. And it allows you to take your Python script and just distribute it, which was one of the limitations that you had in the past, in a very easy way, using still the scalable mechanism that we propose in Glue. And the idea is that it's not about it's about which engine is the right engine for your job, and you can decide if you're a Python user, you can use Python shell or Ray, or you can use PySpark. But the idea is to offer you those capabilities and then let you decide which one is right for your workloads. The next layer that we have is connectors. We have in Glue about 80 plus connectors, and most of our connectors are bidirectional. We have our native connectors, which comes with Glue. And in addition, we do have custom connectors, which many of our customers are using when it comes to, if you have custom systems, if you want to wrap yourself, you can still do that. But in addition, we have dozens of connectors in the marketplace. Those can be to various systems, from niche systems to the industry-specific systems, SaaS applications. And we are adding more and more built-in connectors just because we noticed that customers appreciate it so much. But the idea is that you have the flexibility to choose and to have the right set of connectors based on your source and targets. When it comes to authoring, a lot of it is how we abstract those engines. So what we noticed earlier in the day is we have today 5 different ways to create and author jobs in Glue. What we noticed is that when we started the service, many of our users were Spark developers. And that was great, and they loved the fact that it's serverless. And over the years, we grew within organizations. And to support our customers better, we needed a way to be more inclusive. And we built, 2.5 years ago, we released DataBrew and Glue Studio. So both of them are an abstraction of those engines. You can use Glue Studio, which is a drag and drop components, build your virtual data pipeline. You can use DataBrew for data preparation, which is like an Excel spreadsheet, very easy, low code. And what we do underneath it is to essentially build a Glue job. So you still benefit from all of the platform innovation that we have, but you have a lot more access points for users based on their skills and based on their needs. And late April, we also released our notebook versions. So this is Jupyter Notebooks, which we embed within Glue. We noticed it's an ongoing and popular demand from our customers, and we wanted to support you all. So this is something that we introduced and becoming very popular. And we recently also started supporting a SageMaker Studio notebook. So you can choose Glue as the engines and run your models on top of that. And of course, to many of our existing customers, they can use APIs, they can use their IDE, and work on a code way. This is just an example of what we do. So on the left side, you have Glue Studio. It's a DAG that we built, that a customer has built. What we actually do is generate code for you. It can be Scala, and you can then afterwards, if you want, tweak the codes yourself, which makes it very appealing also to savvy customers that wants to just get started and go deep fast. You can just drag and drop a few of those components and then continue from code, but it gives you the flexibility. And again, we grew kind of like with the developers, but we're adding more and more abstraction to make that more inclusive and to be able to support the growing demand that we have from different organizations. Operationalize is another layer that we are heavily investing on. So when it comes to your job, you author your job, and we looked at it in the diagram, but then you have your third sort of like phase of what happens after post-authoring job. And what we're seeing today is that data engineers actually spend the majority of their time on this phase. And I see a lot of nods here in the crowd. But we estimate that they spend between 60 to 80% of their time. Instead of kind of like creating new pipelines, they spend it on maintaining something failed, what happened. And there is very lack of visibility, and we're investing and doubling down on that. So in Glue Studio, we offer currently various options to do that. We recently introduced our Git integration. That's a native way to integrate to a source control, whether it's GitHub or a few other systems. It helps you because you can parameterize your jobs. You can also move jobs between different environments, whether it's sort of like dev to prod, in an easy way. And you can also apply best practices that are very common in software development, like code review and others. We also have our job monitoring. So no matter how you wrote your job, visual, code, API, you can still monitor your job in a centralized place, see all the job runs, see what fails. And then it's a great visibility to understand what is going on in your environment and to, whenever there is an issue, to dive deep very quickly and understand where this issue happens. And on the very right side is our workflow and orchestration. So we do have our Glue workflows, which are native workflows. But we're also integrating very well with step functions and Airflow. So you can choose your favorite flavor of what you're used to working with and either schedule a job or trigger it by an event. And the last but not least is data management. So we've done kind of like everything from the bottom up, and now is the time where we want to give you as much value when it comes to your data. And we have multiple capabilities here. The first one being data catalog, which probably many of you are familiar with. And the data catalog is one of the most popular metadata today when it comes to data lakes. And essentially, it stores metadata for files or for tables, such as RDS, S3, Hadoop, OpenSearch. And this metadata helps you keep all those silos and track those. In big enterprise or even small enterprise today, we use the best of breed, and there is many different data storage, and you want to keep track of those metadata. If you'll see in the middle, we have sort of like the data catalog, we have also our crawler. And if I need to simplify crawler for a second, it's basically a way to automatically recognize the schema of structured and unstructured files and databases. And it has the ability to also figure out subsequent changes. So whenever your schema changes, you don't need to track that. You'll have that as part of the data catalog. If you're data engineers or ETL developers, you know that this is a great time saver because it helps you mitigate most of the data format and schema-related issues automatically. So without doing it manually, a lot of the time you're seeing a problem and you start looking around, but it essentially is something changed in the schema. And this is a great tool to manage that automatically. We also have, we've noticed in the past few years that, as you might know, there is more regulation and more compliance. And data privacy became key to a lot of customers. And it's interesting because it's sort of like a topic that resides both in the security and governance and also in data. What we can offer in Glue is our aspect, our approach to data sensitivity and sensitive data detection when it comes to data pipelines. So what we can do is that we can recognize PII and sensitive data when it goes through the pipeline. We do that by using pattern matching and machine learning and automatically identify those. We have different types. And you can also build your own. So we have many customers who are using it. The idea is that you don't want to get sensitive data into your data lake. So you can know that ahead of time. It's in the granularity of cell base and column base. So it's pretty granular. And then once you identify sensitive data, you can decide what you want to do with it. You can decide you want a separate column to it, or you actually want to reduce it from the data and not have that in your data lake. And this is how, if you look at the news, you'll see that a lot of the data privacy and sensitive data often occurs in that way. So we want to give you more tools in order to control those. So this was, in a nutshell, Glue, AWS Glue. This is the context you probably need for the Disney, for Ralph to pick up from here. These are various ways that our customers are using us. And I'm going to pass it to Ralph, who will talk and dive deep into the Disney use case when it comes to self-service data integration.
Thank you, Alona. All right. Hey, everyone. My name is Ralph Peterkin. I am a principal technical architect at Disney. I specialize in helping to build data platform for analytics jobs. Quick introduction. I work for the segment of Disney that we call Disney Parks, Experience and Products. And this segment deals with all your leisure activities like your parks, your resorts, cruise ship, Adventures by Disney. We also deal with consumer product like online shopping, Disney. We deal with that. So how did Disney come to use Glue? For us, I think all of you can relate to the words in the top right-hand corner, COVID. I think after COVID, a lot of things locked down, and we needed to get back to the place when the parks were reopening, where we needed to start managing capacity. Social distancing needed to start to take place, and we needed to understand the numbers. We needed to know what was our capacity. Not only that, but were we hitting our mark? So we needed new data sets, we needed new analytical processes in place. So we needed to spin up a new set of jobs, or several different sets of jobs. Well, to understand why we got to this point, first you'll need to understand where we were in our journey with analytical jobs. We were running Hadoop on EC2 instances, and we use the typical stack, which is HDFS, your Yarn, Hive, Spark, Sqoop, some MapReduce. But if you ever play with Hadoop on EC2, you'll know that there are some challenges. It's hard to secure. If you're dealing with Kerberos and refreshing tokens and patching EC2 instances, it's not simple. So you have to divert resources over to maintaining and keeping that Hadoop cluster up and running. Two for us in the challenge bracket was we were hitting capacity, and we needed to start asking ourselves some questions. Three, Hadoop is not scalable outside of the box. You have to do a lot of things to make Hadoop scalable. You have to string a bunch of things together. When you're dealing with, again, security in that, it makes it a little bit difficult. So we got to the point where we start asking the questions from this COVID thing, which is, given the challenges, given the landscape that we have with Hadoop, should we continue with the existing system? And the question that played into that, which is this a COVID thing? I think a lot of us thought that, hey, COVID is going to be here for 2 weeks, and then it turned into 3 months, then it turned into a year. So for us, we were asking the questions when we started this thing was, okay, is this going to be a 2-week thing or a 3-week thing? And if that is the case, do we really need to then scale up Hadoop just to do it? Can we find another tool? So that played into it. But also, for our data engineers and our data scientists, we wanted something to be Spark-based because that's where we're coming from. We didn't want to pick another tool that was going to require more expertise or retraining. And then from those questions, these were kind of the criteria that we came up with. All right? First one was anything that we were picking needed to be serverless. We didn't want to go through the server management, server patching cycles, everything that comes with servers, making sure your security patches are up to date, you are running on the latest software. It's like there's just so much that comes with it. So we wanted a serverless solution. Another thing that we needed is we needed to be fast to market. And what this means is that the solution that we picked, we didn't want to have to layer anything else on top of it. We don't want to have to install any specialized software or anything. We just wanted our developers to get in, write code, and go. And as I said before, it needed to be Spark-based because I didn't want to retrain. I think this, not as important, but cost efficiency was also a play. We didn't want to spend more than we had before. It needed to be lower or about the same. So with that being said, let's jump into some of the technical aspects. Right? So this is kind of our high-level technical architecture. All right, so the first piece is our developer pipeline. In this instance, we have 3 personas that we're catering to. We have our data engineers, we have our software engineers, and we have our platform engineers. Our platform engineers, these are the guys that are going to make sure that from an infrastructure standpoint, everything is golden, right? They're spinning up the Glue environment and all the tooling that comes with Glue to make the ecosystem work. Our software engineers, and I'll get deep dive into this, but our software engineers, these are the developers that are going to be working on our internal Glue framework. And I'll deep dive into internal Glue framework and what that entails. And then our data engineers, those are the guys that are actually going to use what we built to actually get the data products that we need out the door. All right, so when you're talking about spinning up workloads and getting them to scale, one of the things that we found out this really quickly, is that using Glue in the traditional way and how it was designed in terms of like a one-to-one job, it was not going to scale. Because for us, we needed to run tens of thousands of jobs. So what we did was we abstracted Glue, and a Glue job, we actually treated a Glue job and we label it a Glue cluster. And what I mean by this is if you think about EMR, right, or you think about Hadoop, this is actually one contained cluster, meaning that it's run in Spark and you can inject jobs into it. So if you look at this, you'll see that there's one Glue cluster on the top, but then there are several jobs that can be running in parallel. And I'll dive into that. Then you have our data storage layer, which is S3. And for us, we use source raw. You have raw historical, which is when you start to kind of clean your data up. We have syndicated, which is, this is a part where you start to build your data products. And you have curated, which is where we apply any business logic that we need. All right, and there are different terms for this. Popular term now is bronze, silver, gold, but it's the same concept. All right, this was the most important piece for us. It's our control plane. So in order to tie everything together and to provide an interface to actually submit jobs into Glue in the form of a cluster, we just layered on top of the Bodo API with Glue, just some wrappers for ourselves that allow us to run a job, that allow us to stop a job, and also to track a job once we trigger that job. Another piece of a control plane is we just have a visual piece to it where it just pulls in Glue logs to aggregate them so you can actually see what's going on. And allow our users to also submit jobs from that UI. All right, so if you think about this, you now want to build your workflows. So we have our scheduler that talks to the API to say, hey, submit this job on this cluster, and it goes off and run that job for us. All right, so I mentioned briefly that we actually had to build an internal Glue framework. And you might be asking, what are the motivations? Why go build a new Glue framework? There is a Glue framework out there. But our requirements were slightly different, right? So for us, we wanted a standard way to handle some things that were business specific. So in terms of like compliance and different data severity, we needed to have a standard way. What I've found is that if you give 10 developers some piece of code to go right, they're going to come back and they're going to do it 10 different ways. And we just did not want that to happen. We wanted to pull that out, and these specialized things that we needed to happen, we're going to take it and abstract that away and then use that. Not only that, we want it to be as simple as you finding the columns that you want, tagging those columns, and then the framework will take care of all the work underneath the covers. So with this, we provided our developers with this end-to-end tool, which I'm going to actually jump in. Another thing is we did have a SQL base of users, and we wanted to cater towards them as well. So in our internal Glue framework, so just quickly what it is, all it is a single Python code base that uses YAML as a declarative language. So it runs on top of AWS Glue. So you don't have to write Spark code, actually. What you're doing is you're just specifying a couple things with YAML files, and it will take care of it for you. In this framework, there's two pieces. You have your job runner, and you have your job tracker. Who are we really catering to? These are the three groups of people that we're catering to, which is 1, your data engineers, 2, your data scientists, and our data analysts. So what does the flow look like for data? So before you saw in the eye-level architectural diagram kind of moving from this, but this is how we use Glue. So we use Glue as an ETL tool, 1, to move data from raw to syndicated to curated. But also, if you look at raw, we also use Glue as an extract tool. So like any JDBC connections that we need to extract data from, this was actually our replacement for Sqoop, because Sqoop was in our Hadoop cluster, and we wanted a way to pull data out of JDBC databases and actually put them into S3. All right, this is what we came up with in terms of our Glue framework. So I'm going to use a pointer a little bit to get into it, because I know it's, and I'll point on this side. So this is our artifact store for our YAML file. So this is where we keep all the YAML files that we do. This is in S3. And then our Glue framework code is stored in S3. All right, so if we had to go through a normal flow, what this would look like is the scheduler will submit a job to control plane, right, specifying some JSON payload. And in that JSON payload, you'll have things like the Glue cluster you want to put the job on. You also get to tweak the worker that you want to use, so the worker type that you want to use, and provide the config file that you want to use. So when you submit the job to control plane is going to grab the YAML file from S3 that you want and then put it on the Glue cluster to run that job. And that is as simple as it is. And you might ask, why did we do this? Again, the main reason why we did this and we didn't have like 100,000 Glue jobs is if we had a long list of Glue jobs in Glue, it would be difficult to manage. So what we did is we abstracted everything and put them in a manageable way to class things together. All right? So I'm going to take a little bit of time and kind of deep dive into what this declarative language looks like. All right. So there's two main pieces of this declarative language. The first piece is where you define your connections. Right? So if you look here, you'll have a connection that says a raw connection, and that is defined in some S3 endpoint. And from there, if we define all, it's hard to see, but if you define all your connections, then in our action section, you have the ability to use those connections. So let's walk through one real quick. All right. So I want to do an action. So I want to read data from S3 using my raw connections. If you look, there's a raw connection with a filter parameter that says, go to this S3 location and filter on this and read all the data here, right? And then there's also if you notice, there's a raw is, a syndicated connection, which is our write connection. So in here on the flow again, so I want to read from here, and as an output, I'm going to output what I call a data frame, right? So the framework, all it does is take data frames and pass them around. All right, and then I want to go and use a Aurora connection, which I defined on the bottom here, that connects to Aurora DB. I want to use that connection in the read mode. I'm going to pass in the connection, and I'm going to output a new data frame. So now in this case, what we're doing is we're actually taking two data frames. We're reading one from S3, reading one from Aurora, and then we're going to perform a join on those. So we created a join type, and we're going to take those two data frames as input and output a new data frame with this join condition right here. And kind of that's how it works over and over. Now, to cater to our SQL users, you can have user-defined SQL in that YAML markdown. So you can create a user SQL type and then provide the SQL, the Spark SQL command, and it will output a data frame for you. Now, we ran into some problems. There were limitations with AWS Glue initially when we started, and that forced us to actually build several customizations for them. So if you think about any AWS API, once you call them, there are limits to them. So when you're running thousands of jobs or tens of thousands of jobs, you're going to hit those API limits real fast. And what we found is that we could not do a polling mechanism. We had to go to a push model. And that's where EventBridge actually saved us. So with EventBridge, you can set up event rules to look for Glue job status changes, and then use Lambda to push those status changes into DynamoDB. And then our API from our scheduler, when it's going to check the schedule, it will go to check the status, it will actually go to DynamoDB, use the job ID as a key to go get the data, to go get the status of a job. Number two, there was another custom thing that we had to do, which is the way we use Glue. So if you've ever used Glue, you will notice that in the UI, it's not easily searchable. You can only search by a job ID. You cannot search by the parameters that you use to submit the job. You can't search by any special tags. So what we had to do is we actually had to build a solution that help us to get to the point where we can pull the metadata that we're submitting those Glue jobs with and then surface those as dashboards. Similar to Glue, Glue has solved the problem, but we are going a little bit deeper down to the job levels that we're pushing. So what does that dashboard looks like? So this is our dashboard, all right? And there are a couple key things to call out here. The first one is on the top. So if you look on the top there, you'll see that there are several parameters that you can use to filter, right? So you can filter on the job ID, you can go filter on the read part that you pushed, you can filter on the write part. There are several things that you can filter on there. Also, some of the standard things that come with Glue, where you can track how often this job run, when it succeed, when it failed, what worker type you're using to do that. For us, this is important because we want to see for a specific job with certain specific parameters, how is this job performing over time? Is it spiking? Is it working like we expect it to? And on the bottom, error handling is one of the keys. So if you look here, and I don't know how legible it is, but you'll see that we're also pulling out error messages from the Glue jobs and if they fail or not, and over time we can actually capture those and aggregate them. All right, so where are we now? So when we started because of COVID, right? It was a set of COVID workloads that we wanted to spin up and get going for a specific reason. But this started to work so well that we decided that, hey, why not try to migrate some of the workloads off of our Hadoop cluster and see how that works? And you see the tick up, that was working very well. Until we got to the point where we said, why not just get rid of Hadoop altogether and move all our workloads over to Glue? And that is where we are presently. And we are running, I'll say, tens of thousands of jobs, even breaking over, kind of getting to the hundreds, thousands. In conclusion, so AWS Glue has given us the ability to scale our workloads beyond anything that we could ever imagine, right? And what that allows us to do is now focus the resources that we add on our Hadoop cluster to actually focus on building actual data products. And this worked so well that we were able to not only do it domestically, but we were able to take that blueprint that we had and move it and spin up an all-new data platform in Disneyland Paris. All right, thank you. I'm going to hand it over to Alana.